All right, so this is lesson 2. Lesson 2 is comparing data sets of one variable. So today we're going to take a look at the measures of center, right? So that's the mean, median, or the average. Then also look a little bit at distribution and talk about standard deviation and deviation from the mean. All right, so for the first part here, it says measures of center. Data are often compared with each other. Key aspects of data that are compared include measures of center, measures of spread, the shape of the data, and other features such as gaps, clusters, and outliers. So a measure of center is a number that marks the middle of a set of data. The three most important measures of center are the mean, the median, and the mode. So the mean is the sum of the data values divided by the number of the values. So the mean is also our average. So if we want to find the mean of a number, we add up all of the numbers, right? And then we divide by the total number of numbers that we were adding. The median is the number in the middle of a set of data values. So in lesson 1, we looked at the median, right, when we were trying to find the different quartiles of a set of data. So the median is the number in the middle when the data is arranged in order from smallest to largest or largest to smallest. And then finally, the mode. The mode is the value that occurs most often. So this doesn't always show us the middle or the center of a set of data, but it does show us the piece of data that is most frequently seen. So here they go through and give an example of finding the different measures of tendency that you can kind of look at your own. They show you the mean, the median, and the mode. Now let's jump down to this first sample question here. So the sample question says, a transportation agency was deciding between two different routes for a new bus line. On 6 different days, the agency conducted tests to see how long it took the bus to complete each route. These are shown in the table below. Compute the mean times for both routes and use mathematics to explain how you determined your answer. So if we're going to find the mean times, right, what we're going to do is add up each of these times here and then divide by our total number of times, which is 6. So I'd go through here using your calculator. Do 1. And we'll add up each of these. So 45 plus 54 plus 42 plus 52 plus 53 plus 48. And then we're going to divide this number 294 by 6. If we put in that decimal point there, it gives us that the mean for route 1 is 49 minutes. Now we want to find the mean for route 2. We add 49 plus 51 plus 48 plus 56 plus 48 again plus 51. And then also 303, we'll divide this by 6. And we get that it is 50.5 minutes. So that's how we calculate both of the means. And then which route is faster? Well, we would say route 1 is faster because the mean for route 1 was 49 minutes versus the mean for route 2, or the average amount of time for route 2, which was 50.5 minutes. So if you take a look here, right, they give you that explanation up here at the top of page 109. We're going to jump down to measures of spread. So measures of spread tell how much data is spread out or scattered. And the two measures of spread that we are going to look at is interquartile range and the standard deviation. So in lesson 1, we looked at interquartile range, right, which was taking the third quartile and subtracting from it the first quartile. And that interquartile range, right, describes, so the interquartile range describes the middle 50% of the data. Right, so it's that middle chunk of the data that when we were looking at the box plot was made up of the box. So in a 5-number summary of data, the interquartile range is the difference between the first and third quartiles. The interquartile range is less affected by outliers, unlike the mean, which is often greatly affected by outliers. So if we take a look at the interquartile range, if we have one number that's off, it's not really going to change it too much. But it will, however, change the mean a lot. So Another way that we measure spread is standard deviation. So standard deviation, right, measures the difference between each data value of a data set and the mean of the data set. So it finds how far away each piece of data is from the mean, and that standard deviation is computed by taking the square root of the average of the squared differences from the mean. So here's the formula to calculate standard deviation. We used our calculator to calculate standard deviation when we were looking at sets of data. In this lesson here, we don't really have to calculate standard deviation. The thing that is really important about standard deviation is at the very bottom for this lesson. It says, on a graphical representation of a data set, if the data values cover a wide range, the measure of spread is larger, and if the data values are clustered together near a single value, the measure of spread is smaller. So our standard deviation is going to be larger, right? So the standard deviation, larger standard deviation equals a large spread. So if our data is spread out, we have a larger standard deviation. Smaller standard deviation equals a smaller spread. So we'll find that the numbers are closer together, our data is closer together, and really close to the mean. So if we're taking a look at page 110 now, here we've got a question. It says, a company asked 7 employees to turn in receipts for their travel expenses. The expenses were separated into transportation and lodging. The expenses are shown below. So here's our list of expenses, right? So we have transportation, we have the different employees, and we have the lodging. It says, which one was more spread out, the transportation or the lodging? So here we're going to take a look at our interquartile range to find that information. So what I did is our first step was to put all of our data in order of increasing data points here, right? So we started with transportation. I ordered it from 211 all the way up to 912. And then also lodging from 311 all the way up to 612. So just by looking at it, if we were to say which one is more spread out, automatically we'd see transportation, right? The smallest one, or the minimum, is 211 and the maximum is 912. That's pretty spread out. But just to make sure that those aren't outliers, we want to find the interquartile range. So what I did is I started with our 5 number summary like we did in lesson 1 with the minimum and the maximum. Then I found the median, which was the middle number, right, was 460. The first quartile, which was the middle of the first half of the data, was 329. And the third quartile, which was the middle of the second half of the data, which was 902. And then we found the interquartile range by subtracting 902 minus 329 and got 573. So this was our interquartile range, which shows how far the middle 50% of the data was spread out, which is pretty far. Did the same thing over here for lodging, right? So first we arranged it in order from smallest to largest. So we started with 311 all the way up to 612. Right away, we can see that that difference is a little bit smaller than the transportation. But again, we want to check for outliers and look at our interquartile range. So we had to find our 5 number summary. Where we found it, right, was the minimum, the maximum, are given just by looking at the data. Then the median we found to be the middle number here. So if there's 7 pieces of data, right, that fourth one is right in the middle with 3 pieces above and 3 pieces below. So 483 was our median. Then once we found our median, to find the middle of the first half, right, is our middle number here, 350. That was our first quartile. And then finally, the third quartile was 543, which is the middle of the second half of data. To find our interquartile range, we took 543 and subtracted 350 and got 193. So if we go back to the question, question A says, which was more spread out, the transportation expenses or the lodging? If we look at our interquartile range, the interquartile range for transportation was a lot larger than for lodging. So we would say that transportation was more spread out. All right, so we'd say transportation, and our reason would be that the interquartile range is greater. All right. Then B says, the company is planning to send another employee on a business trip. About how much money in all should the company expect the employees to spend on that trip? So here we wanted to find about how much should they expect to pay, which could either use the median or the mean. So if we use the median, right, all we're going to do is take the median from both of these sets of data, transportation and lodging, and add them together. So 460 plus 483, you'd expect to pay $943. If we wanted to take the means and add them together, we would start by adding up all 7 numbers for transportation, dividing it by 7, and getting 573.857. Then we do the same for lodging. Add up the 7 numbers for lodging, divide by 7, get $466.571. And if we added them together, you would expect to pay $1,040.43. So if we use the median, 943, if we use the means, 1,040, these numbers aren't too far apart, right? So either one would be a reasonable estimate for how much money you would expect to spend on that trip. All right, taking a look here at sample 3. So sample 3 is analyzing 2 box plots. So here we have the sales of brand X and brand Y. So this is sales in thousands of dollars. Let's remember what we have with the box plot. Our first point on the box plot is always the min. The second point, or the line here, is the first quartile. The second line here, the third point, is the median, which is also the second quartile. Our third point is the third quartile, and the last is the max. Also remember that when we're dealing with a box plot, 25% of the data is in each section here. So while they might not look the same size, they contain the same amount of data. So here it says which statement can be concluded from the data. So when we're looking at this, we have to check each one of these choices and see which one is true. Which one could you actually conclude here? So the first one says, the mean for brand X is less than the mean for brand Y. Now, in order to calculate the mean, we would need a more clear set of data, and we can't calculate it from the box plot. So both A and B aren't going to be reasonable choices to conclude. While they could be true, we can't tell from a box plot. So now we look at choice C. Choice C says the standard deviation for brand X is less than the standard deviation for brand Y. So remember, when we're looking at a box plot or we're looking at a graph, standard deviation is the spread, how spread out data is. If we look at brand X, is the spread, or how spread out it is, for X less than Y? Well, it looks like it, because X only takes up this much space, while Y takes up nearly the whole set on that number line. So we're going to see that C is probably going to be our right answer, but let's go through and check with D just to make sure. D says the standard deviation for brand X is greater than the standard deviation for brand Y. Well, that's not true because brand X is not spread out more, so it's choice C. Next, you're looking at the shape of data. So here we have different distributions. Uniform, as you can see, everything is even across the way there. Then we have skewed. Skewed is if there is more points of data on one end of the graph rather than the other. So here we have a higher amount of data on the left. So if we were to draw kind of a mountain, right, we have a higher amount on the right. So we say this is skewed to the left because it kind of has a tail that levels off to the left. On the other hand, our next one here, if we look, goes up and then has a tail that goes off to the right. So here we would say this one is skewed to the right. So we have uniform, skewed to the left, skewed to the right. And then if we look here, we have a normal distribution. So normal distribution, right, is often symmetric. So if we're taking a look here, if we draw a line in the middle, the left side looks very similar to the right side. So this is not skewed. It does not have a tail going in either direction and is pretty symmetrical. If we have a normal distribution, this is a case where the mean is a good measure for the middle of the data, right? So the mean is in the middle, and it's a good measure of the typical value in a data set. When it is skewed, either to the left, if we're looking here, either to the left or to the right, then the mean is not, and even a uniform plot there, the mean is not a good use of measure of the typical value in that data set. So only when it is a normal distribution. So if we're taking a look at these 3 dot plots below, and we needed to say whether they are uniform, symmetric, skewed to the left or skewed to the right based on their plot's distribution, we see the first one looks like it is almost symmetric. If we take the middle, it looks like we could fold this left side over on the right side. So we have symmetric here. Plot B, if we were to draw it here, it peaks over on the right side and has a tail off to the left. So we would say skewed left. And then C peaks on the left and has a tail that goes off to the right. So here we are skewed to the right. So the only one that would have somewhat, the mean might be a good measure of this data set would be plot A. However, since they're both kind of off to each side here, it wouldn't really work great with plot A. So now let's take a look at some of the questions that we have here. So these questions are a little bit easier than kind of the ones in the sample area, but we'll still go through them. So it says, for this one here, it says, which histogram best represents a set of data where the mean is the appropriate measure of the center? So the mean is an appropriate measure of the center when we have a normal distribution. So we're looking for the normal distribution. If I'm looking here, this first one, right, has a tail off to the right, so it's skewed to the right, not a normal distribution. If we take a look at the next one here, B is skewed, right, and has a tail to the left, is not a good normal distribution. C, if we take a look here, this one again, not very centered, right? There's not a normal distribution here compared to D. D looks pretty symmetrical. If we were to go down the middle here, the left side and the right side are pretty similar. So we would choose choice D here as being our normal distribution. And when it's a normal distribution, the mean is an appropriate measure of the center. Taking a look at question 2. So question 2 says, the box plots below show the heights of high school students in 2 random samples from 2 different gym classes. So we have the heights of high school students, gym class A, gym class B. Based on the box plots, which comparison best describes the data? So if we want to look at which one best describes this data. A says that students in gym class A are typically shorter than students in gym class B because the difference in the medians of students' heights in the class. So if we look here, the median for A is our number in the middle, which is about 64 inches. So A is 64 inches. And B, the median is about 68 inches. So if we looked here, these are also pretty normal distributions of data, right? Our interquartile range, they seem to be about the same length in terms of the ranges. So comparing the medians is a fair comparison. And this is actually a pretty good description of the data. Now, we don't just want to choose the first answer we get, so we want to make sure that B, C, and D don't necessarily give us answers that would be the best to describe this data before we just go ahead with A and move on. So B says that students in gym A are typically shorter than students in gym B because the difference of the interquartile ranges of the students' heights. So here they're saying the difference of interquartile range. So if we find each interquartile range, right? So for class A, it would be 68 minus 62, which would be 6. And if we found the interquartile range of class B, we're looking at 70 minus 63, which is 7. So since the interquartile range are typically shorter than students in B, that doesn't really measure, that measures the range in that quartile and doesn't really show us that the students are shorter. It just shows that the difference between the first quartile and third quartile is 6 relative to 7. So this range in interquartile just kind of shows that the data is how it's grouped, not necessarily which class is shorter. C says students in gym class A are typically taller than students in gym class B because of the difference in medians. Well, here we found that gym class A, right, their median is 64, gym class B is 68, so they're definitely not taller. And then again, choice D has to do with interquartile range. It says that students in gym class A are typically taller than students in gym class B. Well, we already know that's not true, but also the interquartile range doesn't really show us that. So again, we're looking at choice A, which when we compare the medians, which are a fair comparison here, show us that gym class A is shorter than gym class B. Looking at question 3 here. Question 3 has to do with taking a look at these two histograms here. So it says the histograms below show the ages of cats and dogs adopted at an animal shelter last weekend. So which statement must be true for the data shown for the cats and the dogs' ages? So right away, looking at this data, I can see that the cats' ages are way more spread out than the dogs' ages. The dogs' ages are kind of scattered together here, lumped together here, and they kind of have a uniform distribution. They're not all over the place, while the ages of the cats seem to be kind of random and pretty spread out. So here, A says the mean and the standard deviation of the cat data are greater. Well, definitely the standard deviation is greater because it's more spread out. The mean definitely looks greater too because they have a lot more cats that are over the ages of 5 compared to dogs that don't have any over the ages of 5. So this is probably our choice. Let's just make sure the other ones aren't correct. B says the mean and standard deviation of the dog data is greater. Well, we know that the dog data, the standard deviation or the spread is not greater because they're close together. So it's not B. C says the mean of the cat data is greater and the standard deviation of the dog data is greater. We know the standard deviation of the dog data is not greater, so it's not C. And then D, the mean of the dog data is greater, and the standard deviation of the cat data is greater. While the standard deviation of the cat data is greater because it is more spread out, the mean of the dog data is going to be somewhere around 1 to 2, which is not the case for cats, so it's not going to be greater than the cats, which goes back to choice A, which was our first one, which was correct. All right, question 4 says, the dot plot below shows the results of a sleep study. So we have a control group and a test group. If we take a look at the control group, right, this has data that goes up and then is skewed to the right with a tail that goes off to the right, while our test group seems to have a pretty normal distribution there. So which statement is true of the data? The center of the control group is best measured using the mean. That's not going to be true here because if we look at our control group, it is not a normal distribution. And remember, best measured using the mean means normal distribution. So it's not going to be A there. If we take a look at B, B says the center of the test group is best measured using the mean. So best measured using the mean, again, means normal distribution. We look at the test group. It does look like a normal distribution, so it's probably going to be B. Let's keep looking here. the standard deviation of the control group and the test group are the same. So are the spread the same? That's not going to be true, because if we look at the control group has a tail to the right, so its standard deviation is going to be greater there. Or the standard deviation of the control group is less than the standard deviation of the test group. Again, not going to be correct, because the test group has more points that are closer together, while the control group has a larger spread on them. So again, it's choice B there. Question 5. We're taking a look. It says the box plot below shows the scores on a pretest and a post-test. So we have test scores, we have a pretest and a post-test. Which statement best describes this data? So if we take a look, just looking at these test scores to start, right? So the pretest scores were generally lower, right, and closer together, while the post-test scores were generally higher, right, a little bit higher. The medians were higher, and they were spread out a lot more here. So A says the third quartile is the same for both box plots. Well, the third quartile for the first one is here, and the third quartile for the post-test is here, so they're not the same. The median of the pretest is about 3/4 the median of the post-test. So if we take a look here, the median for the pretest, it's right about here, which is maybe 76. And the median of the post-test is here, which is 80. So 76 is not, if we do 76 over 80, right? 76 is not 3/4 of 80. Not correct there. The interquartile range is about half of the pretest, is about half the interquartile range of the post-test. So they're saying that from here to here is about half the size as here to here. So this one looks a little bit closer. So let's say if we go down here, let's say this is maybe 73 to say 77. So this interquartile range is maybe about 4. And then this post-test goes from 77 to maybe about 87. So it's about 10. Well, 4 is about half of 10, right? It would be better if it was 5, but I think when we're measuring here, we could have been off just by a little bit. So I'd say it's probably going to be C when we're looking at our answer here. Let's just make sure the last one's not correct. It says the difference between the minimum and maximum is the same for both box plots. If we take the minimum and subtract from the maximum, we have a much smaller range for the pretest than we do the post-test, so that's not going to be correct. And our answer about the interquartile range was correct. Now looking at the last question we have here. It says, read the problem and write your answers. Listed below are Janet and Taylor's score from 5 bowling games. So which measure of center would be best to describe each person's typical bowling scores? The mean or the median? So first, what we want to do is take a look at these scores, and let's arrange them in order of smallest to largest, just to make sure that we have a good idea what's going on. So for Janet, we have 89, 97, 101, 102, 164. While for Taylor, we have 172, 178, 192, 195, and 199. So if we're looking at Janet's scores here, Janet's scores are generally all pretty close together here, right? There's a pretty even spread here. So if we're saying the mean, right, when we talk about this outlier of 164, that's going to make the mean a much higher number than what her scores actually are. So if we took the mean, which would be 89 plus 97 plus 101 plus 102 plus 164, all right, and we divided by 5. They're saying her average is 110, or 111 if we round up there. However, if we look at all of her scores, only once did she get a 111, so the mean would not be a good tool for Janet, while the median would be better. The median here would be 101, which is more representative of what she would score. If we take a look at Taylor, let's do the same thing. First, let's find the mean. So if we did 172 plus 178 plus 192 plus 192 plus 199. And again, divided by 5, we get 186. So 186.6 or 187, which is kind of right in the middle of the data that Taylor was bowling. So here we could say the mean would be a good representation for Taylor there. So then here, B, it says, does the person whose data has the greater measure of center also have a greater measure of spread? So Taylor, right, has a greater measure of center, whether you pick the median, which is 192, or the mean, 186. But does that person also have the greater measure of spread? And we would say no, right? If we look at the spread of Taylor's data, it only goes from 172 to 199. Or even looking here, if we go from like in this area here, it's a lot closer together. So no. Taylor's scores are closer together and have a smaller spread. Right? If we looked at Janet's scores, they go from, we have this outlier here, 164, which really changes kind of where the spread of her data would be, right? So if we were looking at this as a curve, right, it would be something that would have a tail going off to the right because of this outlier here at 164. So no, the greater measure of center does not also have a greater measure of spread. So this is the end of lesson 2. Make sure you go on to Schoology and add all of your answers into the quizzes so you can get your credit here moving forward.